Okay, but let's actually do something difficult with this relative motion. So let's say we want the boat to go directly across. So maybe there's a dock on the other side. In order to go directly across, with the river carrying the boat downstream, we have to aim the boat upstream. So our resultant velocity needs to be directly across. That's what we want. We're going to be pulled downstream. Which means we need to angle the boat's heading upward. So velocity of the boat in still water, velocity of the water with respect to the Earth gives us velocity of the boat with respect to the Earth. And we can even double check our notation here. This is velocity of boat with respect to the water plus velocity of the water with respect to the Earth. So our triangle makes sense. I'm going to call this angle alpha. So let's first look at this triangle. This is different from what we had earlier. What we had earlier, we were heading directly across. Velocity of the water is still down, and we are actually being carried down. So notice here, we have swapped what the hypotenuse is. So what does that say? In order to head directly across the river, what does that say about the minimum value for the velocity of the boat? Because the way the triangles work, in order for this to be the hypotenuse, it has to compare to the speed of the water somehow. So I'll let you guys think on that. Okay, so let's figure out, what does our heading need to be? What does our orientation need to be in order to get directly across? In this case, our angle, alpha, we know the speed of the water, we know the speed of the boat relative to the water. So we can use sine alpha, opposite over adjacent. To find the argument of a function, we have to take the inverse. And we get a different answer than what we had before. And notice there's nothing there that would suggest alpha has to be complementary to theta. If it was complementary, we'd be getting like inverse tangent of v sub b over v sub w, and that's not what we're getting here. We're getting a completely different angle. So we can't just say if we drifted 30 degrees starboard, then we should aim 30 degrees to the port side. That's not necessarily true. And we even get a different value for our speed relative to the ground. Pythagorean theorem says this is what we have set up. And so for our speed relative to the ground, we get an entirely different equation compared to what we had if we just aimed straight across. Two different scenarios. So that's probably the hardest thing students struggle with, just because you're drifting 45 degrees downstream doesn't mean that you should aim 45 degrees upstream to go straight. That's not how that works. That's all I got.